This presentation is on the hurricane and the mystery of its maximum winds, presented by Andrew Pavlo, Bimal Vatarai, Joel Luckenball, Rowan Abu Zaina, and Tim Radwanski. Although a hurricane's structure may seem evenly distributed, the destructive forces that hurricanes bring are all but uniform. In the center is a region of light winds and fair weather known as the eye. In the eye, subsiding warm air is found, along with the lowest surface pressures and highest temperatures. On the outside of the eye is the eye wall, which is the most violent part of a hurricane. The eye wall maintains the highest wind speeds, pushing warm air in a spiral toward the top, where it cools and forms more rain clouds. The final formation is the spiral rain bands that radiate outward from the eye wall. These rain bands are organized into regions of sinking and rising air that radiate outward and is where the uneven distribution of wind speeds result. The reason for hurricanes being stronger on the right side is fairly simple. Wind speed and hurricane movement are additive. In the northern hemisphere, hurricanes move counterclockwise. When the wind moves in the direction of the hurricane, the speed of the wind is increased. If the wind is moving against the direction of the hurricane, the net wind speed is less. For example, steering winds of 50 km per hour with additional wind speeds of 175 km per hour results in speeds of 225 km per hour on the right side, while having speeds of 125 km per hour on the left side where the hurricane movement and wind speeds are moving opposite of each other. This applies to the northern hemisphere, where hurricane rotation is counterclockwise. In the southern hemisphere, the effect is opposite. Upon analyzing, it is found that the maximum wind speed results from what is called the gradient balance. This force balance accounts for the centrifugal force, the pressure gradient force, the Coriolis force, and the frictional force. Of these forces, the most apparent is the Coriolis parameter F, which is found using omega, the Earth's angular velocity, and phi, the Earth's latitude. From here, we use the pressure gradient and the radius from the center of the eye to estimate the maximum wind velocity. From figure 3, we can see that the overall reason for the right side being strongest is due to the additive speed from the gradient wind as well as the hurricane's speed from its steering winds. On the left side, the hurricane's movement is resisting the gradient wind, resulting in a slower maximum wind speed. In conclusion, hurricanes are known for their destructive forces of nature, but the structure of the hurricane is far from uniform. The hurricane is made up of the eye and the eye wall. The eye wall is constantly rotating around the eye in a circular motion, while the eye moves on its path of destruction. Ironically, it is actually relatively calm in the eye of the storm, while everything in the eye wall is in serious threat of destruction. Hurricanes have varying wind speeds, and those that travel in the storm's center path have far greater speeds than the wind traveling in the opposite direction. In the northern hemisphere, hurricanes rotate counterclockwise, making wind speeds greater in the east. The wind speed itself can be explained through the gradient balance, which includes the centrifugal force, the pressure gradient force, the Coriolis force, and the frictional force. All of these features and more are what make hurricanes so profound in their nature. This concludes our presentation. Thank you for your time.